there was a star called S2 we observed orbiting close to the black hole, kind of like a comet. It would come in and whip around the black hole, then go back out again. And an S2 at closest approach, when it whips around the black hole, this is a star, goes nearly 20 million miles an hour as it whips around the black hole. And then just recently we found another star that actually gets up to over 50 million miles an hour as the black hole whips it around. And this is how we test the idea that time is different around a black hole. We actually see these stars whipping so close to a black hole, we can tell that there are changes in their orbit, that they're actually going through different time. And so we see these stars whipping around the black hole at the middle of our galaxy. They will probably eventually go down that black hole. I mean, maybe everything in our galaxy will eventually kind of spiral down into that black hole. But, you know, this is not conjectural. These are observations from telescopes. You know, look up S2. Look up, I don't know what the name of the one that goes faster. it's a telephone number. But that's real. Now, the question about what happens if you could survive going into a black hole, and this is another place where we need better physics. Quite honestly, our physics gives up. There are all kinds of wonderful, fascinating possibilities. I mean, people have pointed out this is not observation. Now we're going from observation, we see these things, they're real, to conjecture. People have said that if you take the entire universe, the entire mass of the universe and the radius, the diameter of the observable universe almost exactly matches a black hole. You know, could it be that, you know, inside a black hole, a new universe forms when a black hole forms? Is that what the Big Bang was? Was the Big Bang a black hole forming in another universe and popping off our own universe? Are black holes somehow connected to other universes? These are all incredible questions. We don't yet have the physics to answer them. But, you know, people have said, you know, why is it the universe has about the same density of a black hole, the same size and mass? Is that just a coincidence, or are we looking at something deeper?
Or is it fractal? Is it the entire universe exists inside of a black hole?
Yes, exactly.
That's bananas.
Yeah, there we have the very large array. That was at the that was in Chile. That's a wonderful observatory. There we have a great depiction. Oh, you found, okay, yeah. So
I've never seen a depiction
that's
like
right.
this.
That's the stars moving around a black hole.
Yeah, the
That's
stars moving around a black hole.
bananas.
What's coming? What would this ejection be?
So that, okay, what that is that's a consequence of the black holes that doesn't come from inside the black hole. All of that swirling gas gets really fast. We actually observe some of the swirling gas going close to the speed of light. Black holes, you know, they're going down the drain. They're going faster and faster as you get closer to the black hole. And all of that very, very hot gas generates a very strong magnetic field. And so what you're looking at with those jets is that that's just the magnetic field of the hot gas going around the black hole. Some of that hot gas gets directed into jets by the magnetic field. There's nothing coming out of the black hole. Nothing that we know of comes out of a black hole. But black holes are incredibly, this is wonderfully ironic. They're incredibly bright because if there's gas trying to get around, spinning around a black hole, the gravity accelerates that gas so fast, it spins it up to, in some cases, millions or billions of degrees. You can see them clear across the observable universe. They're the brightest objects in the sky. And this is not light coming from inside the black hole. It's light coming from stuff trapped around the black hole as it spirals in. And these huge jets, we see some of these jets going, you know, in some cases more than 100,000 light years. I mean, they're huge jets that come out.
100,000 light years, and 1 light year is how many trillion miles?
6 trillion miles about. Yeah. So.
Oh my God.
And then in the.
Oh my God.
Yeah. So I mean, around
that video is so nuts.
I've never seen that.
Yeah.
When I was looking for this, or I stumbled across this, I saw a theoretical thing called a white hole. Which is potentially maybe on the other side of a black hole.
You know, no, it's an idea. I mean, that idea, honestly, it had a lot more following, you know, more in like the 60s and 70s. It's kind of fallen out of favor because at first we thought that these hugely bright objects were white holes. At the end of a black hole, maybe the radiation went through a tunnel through space, then came out somewhere. But now we know that these super bright objects are actually hot gas disks around black holes, and they are bright. Like I said, they're the brightest things we know of in the sky. And, you know, so that's something you can see, you know, literally billions of light years away is the hot gas going around a black hole.
You said another thing that broke my brain. You were talking about what the Big Bang is. and that we shouldn't think of the Big Bang as an explosion, but that before the Big Bang, time and space might not have existed.
Well, pretty much certainly not in the way we experience them, no. I mean, once again, no astronomer thinks the Big Bang came from nothing. The problem is, once again, we have no description of what that state of matter would be. None. I mean, the idea that everything we observe of in the universe could have once been at a subatomic scale. You'll notice I'm very careful about this. I talk about the observable universe. We have no idea how big the universe is. We don't know whether it's infinite or whether it has an end. But there's been only a certain amount of time that light has had to travel to us. That's not the whole universe. That's centered on us. That's an effect of we look in every direction in the sky. We can only look back as far as there's been time for light to actually travel to us. And you see some incredible things. I mean, one of the things that one of my friends has the Nobel Prize for is if you look so far away, the farthest away we can see now, we're looking back to a time about 400,000 years after the Big Bang. And this is something where we are actually able to see so far away. We're looking back to a time when the whole universe was hot and bright. It actually was glowing like the surface of the sun, the whole universe. The entire universe was so bright, it was like looking at the surface of the sun. And this this radiation has traveled a long time to get to us. It's now lost energy because it's traveling through the expanding universe. And as the universe expands, the wavelength of light gets stretched out by the expansion of space. This is what we call the microwave background radiation. So there's a microwave, very low energy signal. It comes from every direction on the sky. And it's coming from a distance so far away that the whole universe was as bright as the surface of the sun. And that's as far as we can see, because any farther away from that, the universe is opaque. Literally in every direction on the sky, you eventually look back to a time when the whole universe was so dense and bright, you can't see any farther.
Is this because of how we're capable of measuring? And is it possible that at one point in time, when we get better and better telescopes, that we can look past that?
Well, not with light. See, the universe actually does become opaque to light at that point.
Because it's too long ago.
It's basically the universe is so bright itself. Yeah, I mean, so you look in any direction on the sky. You look back to a time. The wonderful thing about the universe changing is we know this is true. The farther out we look with a telescope, the farther light has had to travel. The more time it takes to get to us. So the sun, we see, the light takes about 8 minutes to get from us to the sun. The nearest star, about 4 years. The nearest galaxy to us, about 2 million years. We can see so far away in space that the light took pretty much the age of the universe to get to us, about 400,000 years after the Big Bang. At that point, the universe becomes opaque to light. So there is a limit to how much we can observe with light, how much time there has been for light to actually get to us.